Electrical system. The S-64 Echo Skycrane electrical power system consists of two power generating systems, an alternating current system and a direct current system. The electrical system consists of the following systems: DC power supply system, an AC power supply system, and external power. AC power supply system. The alternating current system power is supplied by two brushless alternating current generators, a DC operated inverter, and an AC powered external receptacle provide secondary sources of AC power. The AC system consists of the following components: generators, generator switches, current transformer, current limiters, auto transformers, ground inverters, inverter power relay, inverter transfer relay, inverter control relays, under frequency microswitch, supervisory and voltage regulator panels. Component description: generators. Two brushless generators driven by the main transmission accessory section provide three-phase AC power for aircraft equipment operation. Each generator is rated at 20 kVA and delivers 115/208 volts AC at 400 Hz, three-phase power when rotating at 8,000 RPM. The generator contains three main-phase generator windings, a permanent magnet generator, and exciter windings. The exciter windings provide electromagnetic induction into the main generator windings, eliminating brushes and commutators to reduce heat, maintenance, and radio interference. Generator switches. The generator switches are located on the master switch panel on the center console. The switches are marked on, off, reset, and test. Placing the switches to on will connect generator power to the appropriate bus. Placing switches to off reset will take the generator off the line. If a temporary overvoltage condition occurs, placing either switch in the off reset position, then to the on position, will bring the generator back online. The test position is used for generator maintenance checks. Current transformers. Three current transformers for each generator sense the flow of each phase of the generator output feeder line. Each current transformer consists of a number of turns of wire which function as secondary winding, and the transformer is mounted around a generator feeder line that serves as a primary winding. When the generator is supplying AC power, the current transformers produce outputs corresponding to the current flow in each respective feeder line. The transformers for each generator operate in conjunction with the feeder fault transformer, which monitor the current flow of each of the three-phase generator ground return lines. Current limiters. The AC power system contains 6 AC current limiters mounted on a panel in the attic at station 154.5. The current limiters function like slow blow fuses to prevent excessive overloading of the AC generators during transfer conditions. When one generator fails, the primary AC bus loads from the failed generator are supplied AC power through the three limiters in the path from the remaining generator. The current limiters in each circuit permit loss of one or more of the three phases, while the remaining phase or phases remain online. Auto transformers. The number 1 and the compass auto transformer are located on the left attic compartment shelf. The number 2 auto transformer is located on the right attic compartment shelf. The auto transformers convert 115 volts AC to 26 volts AC for excitation of pressure and navigation instruments. Ground inverter. Ground inverter is located in the attic and provides three-phase AC power to essential AC powered equipment and to auto transformers, which provide AC power for pressure instruments before and during engine starts. The ground inverter is rated at 250 volts VA and delivers 115 volts AC at 400 Hz three-phase power when 28 volts DC is applied from the primary bus. Inverter power relay. The inverter power relay is mounted on the left attic compartment shelf. The relay is a single-pole contractor and applies DC power to the ground inverter. When AC power is not available at the primary AC bus, the inverter control switch is placed on. 20 volts DC from the primary bus is supplied to the solenoid of inverter power relay, energizing the relay and applying 20 volts DC power from the primary DC bus to the inverter. Inverter transfer relay. The inverter transfer relays are located on the left attic compartment shelf. The relays, one for number 1 primary AC bus and number 2 primary AC bus, are a 4-pole double-throw contactor relay. The relays transfer 3-phase inverter bus loads from the primary AC buses to the ground inverter when the inverter is the only source of power available. Inverter control relays. Inverter control relays are located on the number 1 relay panel on the left attic compartment shelf. The relays are 2-pole double-throw contactor relays. When the relays are de-energized, normally closed contactors provide a DC voltage path from the inverter control switch in the on position to the solenoids of the inverter transfer relays. The inverter transfer relays in turn allow power to be applied to the inverter and connect inverter loads to the inverter AC output. The path from the solenoid of the number 1 inverter control relay is routed through the contacts of the closed inverter control switch to the number 1 primary bus and the path. Under-frequency microswitch. An under-frequency microswitch is mounted on both the left and right main landing gear in the air. The switch contacts are closed, providing a path to ground the air-ground relay. This is for the under-frequency portion of the supervisory and voltage regulator panels, the HRS, weather radar, and auto reignition. On the ground, each switch is normally open. The switch is attached to a bracket on the lower end of the main landing gear housing and to the upper torque arm. The switch is actuated by the movement of the torque arms. Supervisory and voltage regulator panels. The supervisory and voltage regulator panels are located in the attic. The panels contain the control and protective functions for the AC generators. The panel is fully transistorized and except for the relays, has no moving parts. The panel provides excitation to the generator exciter field when the generator is rotating and no initial external source of power is required. The panel incorporates a voltage regulator which controls the generators by varying generator output voltage exciter field current as necessary. Should a malfunction due to overvoltage or undervoltage, underfrequency, or feeder fault occur, the panel will remove the generator from the AC primary bus and light the appropriate caution panel generator light. If the malfunction for the overvoltage, undervoltage, or feeder fault no longer exists, the supervisory and voltage regulator panel may be reset and generator operation restored by placing the gen switch to off reset and back to on. Should an under-frequency condition exist, panel will remove the generator from the primary AC bus but not disable the generator. If the frequency increases to 4 Hz or more, the panel will automatically reset and return the generator to an on-line condition. When helicopter is airborne, the under-frequency switch on the main landing gear scissors disables the under-frequency circuit. Auto transformers. 3 transformers located in the attic each receive power from a respective AC primary bus when energized, or receive power from the ground inverter when the AC primary buses are not energized. Auto transformers step AC voltage down from 115 volts to 26 volts for operation of some engine and navigational instruments. AC system theory of operation. The AC system sequence of operations divided into 2 control sequence modes, normal power and transfer power. Normal power mode occurs when both generators are operating, selected and online. Each generator output is directed through a supervisory panel that provides control and feeder fault protection and protects the system from underfrequency, undervoltage, and overvoltage. The underfrequency protection is not available when the weight of the helicopter is removed from the landing gear wheels. Power is directed to the primary and monitored bus of each generator. Transfer power mode. Transfer control sequence occurs when the one generator fails. Power is dropped from the operating generator's monitored bus and directed to the non-operating generator's primary bus. Current limiters protect the operating generator from an overload in the event of a short in the non-operating generator's primary bus. DC power supply system description. The DC power is supplied by two 28-volt, 200 ampere converters, transformer rectifiers, with a battery and DC external power receptacle, providing secondary sources of DC power. The DC system consists of the following components: converters, which are transformer rectifiers, converter switches, reverse current cutout relays, battery switches, battery relay, battery. Converters, as in transformer rectifiers. The number 1 and the number 2 transformer rectifiers convert generator 115 volts AC power to 28 volts DC power and are powered by a respective generator and AC primary bus. Each transformer rectifier is controlled by a switch located on the center console and protected by a circuit breaker marked number 1 converter and number 2 converter, respectively, located on the overhead circuit breaker panel. The transformer rectifiers are connected directly to the DC system whenever they are energized by AC power, and the rect switches are in the norm position. Converters switches. The converter switches, marked X-former rect, are located on the center console. Each switch has two positions: off and number 1 for the number 1 switch, and off and number 2 for the number 2 switch. The number 1 or number 2 position is the same as on. When either or both switches are placed to the on position, DC power is connected through the reverse cutout relay to the primary and monitor buses. With both switches in the off position and the battery in the on position, battery power only will be available to the primary bus. Reverse current cutout relays. The number 1 and number 2 reverse current cutout relays apply the 28 volts DC output from the number 1 and number 2 converters to the primary DC bus. Should a converter fail, open, or become shorted, the associated reverse current cutout relay removes the converter output from the DC primary bus. Battery. The 24 volt, 22 ampere hour lead acid battery is located in the left side of the electronic compartment below the cockpit and is accessible from the outside for maintenance. Battery power is used for limited ground operations and as an emergency source of power to the DC primary bus, should both generators or both converters fail. If either converter is on, they will replenish the battery charge when the battery is in the on position. Battery switch. The battery switch located on the center console, marked BAT, has marked positions on and off. When the switch is placed in the on position, battery power is supplied to the DC primary bus. Placing the switch in the off position will disconnect the battery power from the DC primary bus. Battery relay. The battery relay is bolted to the upper right beam in the nose electronics compartment at station 42. The relay is a single pole contactor relay. It applies 28 volts DC power from the battery to the primary bus. With the battery installed and the console BAT switch placed on, the battery voltage through the relay is completed to ground, closing the contacts and directing power to the 28 volts DC primary bus. DC system theory of operation. The DC system power is supplied by two 28 volt, 200 ampere converters, which are transformer rectifiers. Power is distributed through a primary. Operation is automatic. The primary bus supplies all equipment necessary for maintaining normal flight. The primary bus is powered by both converters when their switches are placed in a norm position, or by either converter should one fail. The primary bus is also powered by an external power source when connected, and the external power switch is in the on position. A monitored bus, which was initially designed to supply power to maintenance receptacles, has been disabled by EAC. The circuit breaker panel, labeled DC primary bus auxiliary, is linked to the primary DC circuit breaker panel and contains fire retardant tank, upper and lower hook, pendant load cell, and N1 and N2 circuit breakers. A lead acid battery supplies DC power when no other source is available. External power supply system description. The external power supply system provides a means of applying AC or DC electrical power to the helicopter from an outside source during ground operations. The external power supply consists of the following compartments: AC external power receptacle, AC external power control relay, DC external power receptacle, DC external power relay, diodes. AC external power receptacle. The AC external power receptacle is located on the right side of the helicopter, forward of the right electronics compartment door, below the cockpit floor. AC external power receptacle permits three-phase AC power from an AC auxiliary power unit to be applied to the helicopter electrical system during ground operations. The receptacle contains 3 pins for power connection and 2 additional pins that are jumpered, forming an interlock when the auxiliary power unit is connected. Jumpered pins complete a path for control relay activation and lighting of the caution advisory panel. X power connected advisory light. AC external power control relay. The AC external power control relay is located on the right attic compartment shelf. The relay is a double pole, double throw contactor relay. When AC external power is applied to the helicopter and the generators are not supplying power, the normally closed contacts complete the path of DC control voltage from the external power monitor panel to the external power primary and monitor bus relays. With external power primary and monitored bus relays energized, AC external power is applied to the helicopter buses for distribution. If either or both generators become available to provide AC power and one or both primary bus relays become energized, DC voltage from the auxiliary contactors of one or both relays is applied to the solenoid of the AC external power control relay. The AC external power control relay energizes and the normally closed contacts open, interrupting the path to the external power relays. DC external power receptacle. The DC power receptacle is located on the right side of the helicopter, forward of the electronics compartment door. The receptacle permits DC power from an auxiliary power unit to be applied to the helicopter electrical system during ground operations. The 3-pin receptacle contains current common ground pin, a high current pin, and an additional low current pin to provide DC control voltages for relay excitation and lighting of the caution advisory panel, external power connected light. DC external power relay. The DC external power relay is mounted on the upper right-hand beam in the nose electronics compartment at station 42. The DC power relay is a single pole contact relay. It applies 28 volts DC from the 28 volts DC power from the external DC power receptacle to the helicopter DC power system. Diodes. 4 blocking diodes function as gates during AC or DC external power application to prevent the flow of DC control voltage along undesired paths. External power supply. When external power is connected, a jumper wire in the connector directs 28 volts DC power from the primary DC bus to the advisory panel external power connected light. When the external power switch is placed to the on position, external AC power is directed to the number 1 and number 2 primary buses. If either or both generators are activated, AC bus loads will be removed from the auxiliary power unit and normal power will be restored. If external power requirements do not meet requirements of external power monitor panel, a relay in the panel will not open, de-energizing the primary and monitored bus relays, removing all aircraft loads from external power. Reset capabilities is provided through the external power reset switch, which energizes a relay in the external power monitor panel to supply power to the primary and monitored bus relays. If the fault remains, the relay within the panel will again de-energize.